In Lesson 3-5, we will be discussing modeling with nonlinear regression. In Video 3.5.4, the learning target will be for students to determine the appropriate type of regression to model a given set of data. In Example 4, you're asked to choose a type of regression. In this example, use the data in the table to determine a regression equation that best relates the profit of a website with the time it has been in business. Then determine the approximate time it will take for the website to earn a profit of $100,000 in 1 year. So in this example, we're given two different variables, years and profit. X represents the number of years the website has been in business. Y represents the profit that it's made. What we are going to do is enter this data into our lists in our calculator. So we're going to choose the Stat button and then Edit. And we will enter the data. The years will be in list 1 and our profit will be entered into list 2. So go ahead and pause the video while you enter this data into your calculator. After entering the data into your list, we are going to make sure that we have our stat plot turned on. So you can press second and then y equals to get to your stat plot menu. And make sure that the stat plot is turned on. Stat plot. Make sure it's turned on and that your data is in list 1 and list 2. And that you also have the scatter plot chosen as the type of graph. Next, we'll go to the window and set up our window for this set of data. In my X minimum, I'm going to put 0. X maximum, I'm going to say 10. X scale, I'm going to say 1. Y minimum, Y maximum, and Y scale, I'm going to say 0 for Y minimum, 40,000 for Y maximum. I think the largest Y value in our table was like 31,000. And then our Y scale, I'll say count by 10,000s. After that you have set up your window, which the window button is right here next to Y equals, you can go ahead and select the graph button and it should show you your scatter plot. Our scatter plot should look something similar to the graph given to me here by the book. Here they used a different Y value, Y minimum, Y maximum. The Y minimum is the same, but the Y maximum they set to 60. So they must have converted or divided all the numbers in the Y column of our data table by 1,000. Because we went up to, I think, 40,000, and they're saying basically they're going up to 60,000, but they just divided all the Y values by 1,000. So they got numbers in the 10s. 20s, 30s, 40s, 50s, and 60s. So after this, after we have our scatter plot, it looks like our function can best be modeled by an exponential curve. I would say that this right here best looks like a exponential model. So we're going to go on the next slide and calculate an exponential regression equation for this model and see how high our correlation coefficient is to see if our hypothesis is correct. To calculate an exponential regression, we are going to go back to the stat button, go back to the stat menu, and instead of choosing edit this time, which we did when we entered our data into the list, we are going to choose the calculate menu, which is at the top. So arrow over to calc at the top, and then underneath the calc menu there's several types of regression. We want to choose exponential regression, which I think is at the very bottom of that menu. You have to scroll down quite a ways. I think it's maybe option number 9 or 0. It is number 0. It's number 0 on that menu. Okay, so once you choose exponential regression, you are going to have to tell the calculator what lists your data are in. So on my calculator, it'll bring me back to the main screen. Not everyone's does this, but I have the older version of the calculator, so it'll bring me back to the main screen, and I'll tell the calculator my data is in list 1, comma, list 2. Now, list 1 can be found, that L1 can be found by pressing second and 1. The comma button is right here, and then L2 can be found by pressing second and 2. Now, once you do that, you can press enter. Once you press the enter button, that'll give you the exponential equation. Those of you that have the newer operating system on the calculator, you can just make sure your data is in list 1 and list 2 and then press calculate. So then we'll just press enter, and it should give us the equation in the general form is y equals a times b to the power of x. In here it tells me the value of a is 999.99, and our b value is 1.78, and then our r value, our correlation coefficient, is 1, which means that this is definitely an exponential function because it is 100% match with the data given. So if I were to graph this exponential function, it should go exactly through the center of all the points on our scatter plot. One thing I want to point out when you're choosing the type of regression, we've learned about different types of functions this year. You can choose linear regression, quadratic regression, cubic regression, natural log or logarithmic regression, exponential regression, power regression, and logistic regression. And the way you can tell if an equation is a good fit for a set of data is by that R value. Our correlation coefficient tells us how closely that model fits the data. And so, although I looked at the scatter plot and kind of knew it was going to be an exponential regression, if I got a poor R value with exponential regression, I could go back and try some of these other types of regression to see which one of these gives me the highest R value possible for that set of data. Now, since exponential regression was perfect, I don't need to go and try any of those other types of regression. And I'm going to use P of t equals 1,000 times 1.78 to the t as my exponential model for this function. What you should do after you have your equation chosen, which we've chosen exponential growth function because our correlation coefficient was perfect, we are going to paste that equation into our equation editor, or y equals. So go to y equals and make sure that under y1 you have your equation. If there is an equation there, delete it or clear it out. And then once you have your cursor in y1, I'll have your cursor blink in there. What I want you to do is go to the vars button. So if you go to vars, and then underneath the vars menu, choose option number 5, which is statistics. And number 4, once we get to statistics, we're going to arrow over. So at the top, choose EQ. There should be an EQ menu about 2 or 3 spaces over. And then in the EQ menu, I want you to choose Reg EQ, which is option number 1. And what this should do is it should paste your equation into your equation editor. And then after you have that equation pasted there, you're going to press graph, and you'll see your equation, your exponential function graphed over the top of your scatter plot. Now what you should see when you graph your exponential function, and yours might look slightly different because, again, we had a different window than the book did, but you should see your exponential function go through the center of all your points, confirming that our R value was equal to 1 and that this was a perfect fit. An exponential growth function is the perfect fit for this set of data. In the last part of this problem, we need to determine when the website will make a $100,000 profit in 1 year. And so to do this, what you need to do on your calculator is we already have our model stored in Y1, right? This is what we have in Y1 right now. Y2, we want to store the number 100,000 because that's what we want to know is when our profit or our Y value is going to be $100,000. Now, in order to graph Y equals 100,000, I need to make my window bigger because remember, our window only went up to 40,000. We had Y comma Y minimum at 0 and our Y maximum at 40,000. I need to change that Y maximum in my window to 100,000. Actually, I'm going to do a little more than 100,000 and say 120,000. That'll give us some extra room at the top of our viewing window or screen. So what I'm going to do is graph this function. Here they've set their Y maximum at 150,000. And again, you can change your scale to count by 5,000s like they did. And what I want to know is that line Y equals 100,000 goes right here. And here's our exponential model. If we want to know when our exponential model reaches 100,000, that occurs right here at the point of intersection. And so to calculate that point of intersection, I'm going to use the calculate intersection feature on my calculator. So to do that, I need to go to second and then trace at the top of my calculator. That'll give me the calculate menu. If I press second and trace, which is that home row at the top, the very, very top row of buttons on your calculator, you'll see calc above trace. And then if you select that menu, option number 5 is intersect, I believe. And what that'll do is it'll bring you back to your graph once you select intersect, and you can place your cursor near the point of intersection, and then you're going to press enter 3 times. It'll say first curve, you can press enter. Second curve, you can press enter. Third, or the guess part, you can press enter, and it should give you this exact point of intersection right here at the bottom of your screen, which tells us that our Y value will reach 100,000 after 7.98 years. So we could say approximately 8 years if we wanted to, or we could round to the nearest hundredth like they did and say our profit in 1 year it'll take us almost 8 years or 7.99 years to reach a profit of $100,000 in a year. In example 4 guided practice, we're asked to use the data in the table to determine a regression equation that best relates the profit of a business with the time it has been in business. Time in years and profit in 100,000s is given. You have 4 options as your different type of regression, A, B, C, and D. I would like you to pick the type of regression that best fits this data. So I'd like you to enter this data into your list, look at your scatter plot, and then determine whether you should use a linear regression, a power regression, an exponential regression, or a quadratic regression to model this set of data. And when you're looking at these different types of regression, I would like you to use your R value or correlation coefficient to determine which of those models is the best fit. Once you have selected your answer, press submit and you are finished.